In this introduction to Fiatlight, we'll explore how to create a simple GUI for functions, how to compose functions, how to customize the GUI for your needs, and how Fiatlight saves the application state. By the end of this video, you will have a solid understanding of how to use Fiatlight to build interactive applications. Let's see how to create a simple GUI for functions. We'll start with a basic function that adds two integers. In order to create a GUI for it, we simply import Fiatlight, then run the function via Fiatlight. We can then interactively play with our function. We can enter input parameters and see the output result. Widgets are generated automatically depending on the parameters type. For this dummy function, which accepts parameters of type string, integer, boolean, and enum, we will have a text input, an integer or float entry widget, two checkboxes where the second handles are optional boolean parameter, and a combo box for the enum. Let's have a quick tour of the user interface. In Fiatlight, functions are presented as nodes inside an infinite canvas. Use the mouse wheel to zoom in or out the full canvas. Right-click and drag anywhere in the canvas to move the full canvas. Drag the function node to move it inside the canvas. Inside a function node, the I button will show the function documentation, which can be formatted using Markdown. The Collapse All button enables to collapse a node. The eyes buttons enable to show or hide the inputs or outputs of the function. The copy to clipboard button is self-explanatory. This button enables to open the function in a distinct window. This can be useful if you have a graph with lots of functions. You can even dock this window to the side. Let's see how we can compose functions with Fiatlight. In this example, we will compose two simple image processing functions, read image and detect edges using the Canny algorithm. Note that we are using two types from Fiatlight, image path and image RGB, which are synonyms for a string and a NumPy array respectively. Image path will be presented in the GUI as a file selector, and image RGB will be presented with a widget to display the image. Then we use Fiatlight run to run the application, passing the two functions as a list. The output of the first function will be passed as input to the second function for its first parameter. When we run the application, we get a GUI with two nodes, read image and detect edges. We can see that the output of the first node is connected to the input of the second node. We can select an image file in the first node. We click on plus, then we select our image file. After we selected our image, we can see it in the first node's output and the detected edges in the second node's output. You can then adjust the parameters of the detect edges node to see how it affects the output. These images widgets can be resized, zoomed, and panned in a synchronized way. With high zoom, you can see the pixel values. You can also save the images or send them to an inspector tab for further analysis. Fiatlight is provided with a command line utility. Simply run Fiatlight in a console to use it. It provides three different modes, which we will cover in this video: types, GUI, and FN attrs. With Fiatlight types, you can list all supported types and their corresponding GUI. With Fiatlight types path, you can filter types related to path. There we can see the image path, which we previously used, and which provides a file picker dialog for selecting image files. Let's see how we can customize the GUI using fiat attributes. Here we continue from the previous image example. Going back to the Fiatlight command line interface, we can see that we can get info on how to customize the GUI for float parameters by typing Fiatlight GUI float. There we can see customization options such as range, edit type, slider logarithmic, label, tooltip, etc. We will use some of these options to customize the GUI for the detect edges function. For this, we will use the add fiat attributes function, which enables us to add customizations to the GUI for an existing function. To customize the GUI for a function parameter, we use the following naming convention: parameter name followed by two underscores followed by the attribute name. Here we will customize the low threshold and high threshold parameters of the detect edges function. Then, going back to the Fiatlight command line interface, we can see that we can get info on how to customize the GUI at a function level by typing Fiatlight fn attrs. There, we can see customization options such as label, invoke async, etc. Let's add a label to our function by simply adding label as an argument to add fiat attributes. Let's now add a label to the read image function. This time, instead of using add fiat attributes, we will use the decorator named with fiat attributes to add the label directly to the function definition. This is shorter but more intrusive as it modifies the function definition itself. Then we can see that our GUI is updated with our customizations. Our functions labels are applied, and the two thresholds are now sliders with logarithmic scale and a range from 0 to 5,000. Let's see how Fiatlight can handle functions which take more time to execute. First, we will add a delay in the detect edges function to simulate a long processing time. Then, using the command line fiatlight fn attrs, we can see that invoke async enables to run the function in a separate thread so that the GUI remains responsive. We may also set invoke manually to avoid running the function automatically when an input changes. This is completely up to you, depending on your use case. So we will add these two attributes to our detect edges function, invoke async and invoke manually. Then in the user interface, we can see that when we change a parameter, the function is not invoked automatically. Instead, we have to click on a button near the label refresh needed to invoke the function. While the function is running, the user interface remains responsive, and you can see a spinning icon in the top right corner of the node. Let's see how Fiatlight saves the application state. Each time you exit the application, the current state is saved. This includes the values of all parameters, the positions and status of all functions nodes in the graph, the size and location of the application window. Let's demonstrate this by changing some parameter values and moving some function nodes around. Then let's quit the application. When you restart the application, the previous state is automatically restored. This allows you to pick up right where you left off. The settings are saved in a folder named fiat_settings in the current working directory. By default, they will use the name of the Python script that was used to start the application. You can also specify a custom name. The app name parameter of the run function will also be used for the settings file. You can also manually save the current state at any time using the File Save menu. Later, you can reload this saved state using the File Load menu. With only two functions plus a call to Fiatlight Run, we could create a complete application, including customized GUI and save load functionality.